Hey everyone, here's a quick help with problem number 23 from section 2.6, related rates. So that's the one with the pool, and there's water, and let's just see if we can draw a little bit of water in there just to get the idea. And so we have this whole thing, okay? So there's our water, and it's getting filled up and all that kind of stuff. So the water's down here. Great, looks a lot like water. Miss Bourbon does a great job of coloring stuff in. All right, so we know that the volume of this whole thing, also there's this an extra little box that kind of, let's do this in black. There's this extra little box here that, there we go, there's an extra box that's on top. So we have this little bit more that we have to do, so it's not just going to be like a triangular prism kind of a thing, it's going to be a little bit more. So there's like this extra rectangular prism that goes on top. So the volume of this whole thing is going to be the volume of the triangular prism plus the volume of the rectangular prism, and I have all this right in here. Alright, so what we're going to do is we're also going to label this, and based on the book we know that this length all the way across here, I'm going to write it down here, is 12. The height of the whole thing is 3 from the top all the way to the bottom, and then the width across here is 6. So I know my picture's not that accurate, but it doesn't really matter how accurate my picture is because we're going to use it just as a helpful guide. If you want to look at the picture, go to the book and look at the picture exactly. Alright. So we also know that this is 1 right here. Okay, so 1 goes from here to here. So we're going to say volume of this thing, we're just going to say 1 is base, 1 is height, and 1 is width. I think the width is going to be 6. So I'm going to say base and height. Let's say the base is 12. Okay, so it's going to be 12 is the base. And then the height is not going to be a total of 3 because the triangular prism only goes up here. It's actually going to be 2. And then the width is going to be 6. Alright, so far so good. And then we're going to do the same thing for this. What's the base of this rectangular triangle? It goes, or the rectangular prism, it goes all the way across, and that's going to be a 12. The height is going to be 1, so the 2, this 2 here and this 1 here are going to add up to the total of 3 for that height, and then the width is also going to be 6. Okay, so if we go through and actually calculate all that volume, it should be 144, is it cubic centimeters, cubic inches, cubic meters, what is it? Cubic meters. It's meters cubed. If you don't believe me, go through half of 6 times 2 times 6, all that kind of stuff. Alright, so it's 144. So we know that's the full volume that's possible. Okay, so now that's part A. Alright, so now what we have to do is we have to figure out, excuse me, if we're only going up to 1. So let's say this is going to be a 1 instead of going all the way up to 2, right? We've only filled it up about halfway up. So we need to kind of use this exact same thing. So this is the total volume. So let's just call this total volume. Alright, so that's our total volume. Now let's talk about what is the volume if we fill it up just to 1 meter. Well, we don't care about the rectangular prism for that part, right? Because all we really care about is the triangular prism because we have nothing that's up there. So we can say this volume is going to equal 1/2 base times height times width, right? We don't care about the rectangular prism. It's not there. So we know the volume is going to equal 1/2. We don't know what the base is yet, but we know the height is 1, and we know the width is 6. So what we have to do is we have to try and figure out what is that number. How far across do we go? Well, use your idea of slope, and that should help. If I go up 2, I went right 12, or left 12, I guess. Up 2, left 12. If I go up 1, I should go left 12. If I go half of 2 is 1, half of 12 is 6. So actually, this whole thing is proportional, and it's going to be a 6 all the way through. Alright? So when I go through that and I get my answer, my volume for this one should be 18 meters cubed. So I've got the possible cubic meters and the total cubic meters. So part A, the last part of part A, tells us to take what's the percent of it that is filled. Well, for part A, we can take 18 meters cubed over 144 meters cubed. And you're going to get an answer, a ratio, and we're going to change that to 12.5. That's a really good 2. Let's go back and just do that again. 12.5%. Alright, so there is the full answer for part A. Alright, now on to part B. Let's do part B here right now. So part B, it says, what is the rate at which the water is rising up? Correct? It says yes. At what rate is the water level rising? So we want to know how fast is it going up right here, right? So the things that we know, do we know dV dt? Yes, dV dt equals 1/4 of a meter cubed per minute. That was right in that picture, okay? So we know dV dt, and we're going to use this formula. Now we have B's and H's and W's and all that kind of stuff, and we need to figure out all of that. So what we're going to try and do is get this to as few of these variables as possible, okay? So what I know is, I'm actually going to move this thing over here a little bit. We're just going to, whoops, I didn't want to do that. Come on here. There we go. We're going to take this, and we're just going to move it off to the side. Oh, come on. Move this off to the side, and then we have to move this back. And then we have to move this back. There we go. Okay, so first, we know that this width is not changing. It's going to be the constant thing. It's that width of the pool is not going to change no matter what. So that width is always going to be 6. Okay, so plus and then B times H. All right, so one thing we know about this part, we go 1 in the height, we're going 6 in the width, right? So the 1 height is the same as going 6 in the width, right? So, or in the, I guess I called it a base before, so we're going to say 6b, not 6w. 6b, not 6w. So we're going to say 1h is going to be 6b times b times 6. And then this base and this height are going to just be, I was just checking, I'll make sure that I get that. I think we can just do that whole thing. I think we can just leave it just like that. Okay, so we're not going to worry about anything else right now. We're just going to write that. So we say V equals, and we're going to get 36 1/2 is 18b squared. That's a little bit better because now we only have one variable and nothing else. Okay, so now we're going to rewrite this. Find the derivative. dv over dt equals 36b times db over dt. Well, we know how much the base is changing because, actually we don't know how much the base is changing, that's what we're trying to find out. We know how much the volume is changing, so we're going to take this and plug it in for that guy right over there, right? So we can say 1/4 is going to equal 36b db dt. Okay, so now what else do we know? Good question. Answer in a second. Alright, so now we know, here's the one thing, like if we didn't have this b here, then we'd be able to find this no problem. But what we're going to look at is what is the height right here of the water. The height of the water is just 1. So we can really say this is 1/4 equals 36 times 1 db dt. Right? That's not looking so good, but okay, that's fine. Yeah. So now we can divide by 36, and we end up, and I kind of run in a room here, I'm going to say 1 out of 144 is going to equal dB over dt. And then what we should be able to do is say this is going to be 1 out of 144 meters per minute. And I have my units, it's not meters or meters cubed or meters squared because we're talking about a length, which is going to be a meter. So it's going to go 1/144th of a meter per minute. If you think about a big pool, that's not a lot because there's a lot of volume that needs to be going in that pool. So there's part B right there. Okay, there you go. Hope that helped.